Okay, your last set of practice problems were on your circular motion worksheet, numbers 1 to 6. Number 1 says, a car approaches a level circular curve with a radius of 45 meters. So R is 45 meters. If the concrete pavement is dry, coefficient of friction of 0.12, and this is static coefficient of friction, okay? What is the maximum speed which the car can negotiate the curve at constant speed? Now you might say, how can this be static? It can be static because this friction is acting as the centripetal force, and it's keeping the car's moving this way. But the friction isn't opposing the motion. This friction is what's acting as the centripetal force on the side of the wheels of the car. It's actually pushing inward. Okay, so this is FFR, which has to be equal to FC. And the question wants to know, what is the speed? V. And the curve is level. So we know that FFR has to equal FC, which means mu Fn is equal to mv squared over r. And Fn is just going to be mg because it's a level curve. If we were to look at it from the side, right, there'd be gravity going down and the normal force going up. Okay, so this will be mu mg is equal to mv squared over r, and the m's cancel. And you're looking for v, so take your r up. So v squared is equal to mu g times r. So v squared is equal to 1.2, 9.81 meters per second squared. And your r was 45 meters. Okay, remember that's v squared. You're going to have to take the square root. So if you got something like 529.79, which seems awfully fast, it is because that is v squared. Take the square root and you get 23.02 meters per second. Okay, now an important thing to note here is that the masses cancel. And that's a really good thing. That means if you've ever seen those warning signs when you're going into a curve, like, and it says 70 or 50 or whatever, well, if the masses didn't cancel here, then how fast you would go would depend on what car you were in. And there'd have to be a whole bunch of different speed signs, and you'd have to be looking, okay, that's a smart car, I'm bigger than that, and that's a Toyota Corolla, I think I'm bigger than that, oh, but that's a minivan and I'm smaller, and it could be really distracting. So it doesn't matter if you're in a smart car, a Toyota Corolla, or a minivan, you can still go around this curve at the same speed, assuming the tires on all the vehicles are the same. Number 2, a ball is swung in a horizontal circle. So it's going to be like this. Okay, radius is 1.25 meters. The uniform speed, the ball has a centripetal acceleration, AC, of 1.25 meters per second squared, and it wants to know what is the speed, what is v. Okay, and our centripetal acceleration equation is AC is equal to v squared over r. So AC, you're looking for v, so v squared is equal to AC times r. So v squared is equal to 1.25 meters per second squared times 1.25 meters. And then you're going to take the square root, and I bet you get 1.25 meters per second. Funny about that when you multiply 1.25 by 1.25 and take the square root. Number 3. A race car goes around a level circular track with a radius of 1 kilometer, or 1,000 meters, at a speed of 120 kilometers per hour. So v is 120 kilometers per hour. And when you change that into meters per second, it's 33.3 repeating. What is the centripetal acceleration? So again, AC is equal to v squared over r. So 33.3 repeating meters per second, and that gets squared over 1,000 meters. And you should get, if you remember to square your 33.3, you should get 1.11 repeating meters per second squared. Number 4 says a car enters a circular curve with a radius of 0.4 of a kilometer. So in other words, 400 meters at a constant speed of 83 kilometers per hour. So V is 83 kilometers per hour. When you switch that to meters per second, it's 23.05, I believe, with the 5 repeating. I'm just going to check that. Oh, I don't know what I just did. 83. I did 23. Yeah, 5 repeating. The friction between the road and the tires can supply a centripetal force of 1.25 meters per second squared. Can the car negotiate the curve? So the max you can get is max acceleration that you can have is this. This is how much the curve will allow you to go. So let's find out how much it is you're trying to go. So V squared over R. So 23.05 repeating meters per second, and you're going to square that and divide it by 400 meters. And when you do this, you get a centripetal acceleration of 1.3 meters per second squared. But the most the curve will allow is 1.25. So no, you cannot go around the curve at the speed that you're trying to. You will go off tangent to the circle. Number 5, you swing a ball on a string over your head at a constant speed in a horizontal circle. So this way again. Okay? With a radius of 1.5 meters. If the object takes delta t 1.2 seconds, which is really the period, right? It takes 1.2 seconds to go around. What is the object's speed? So you need your v equals 2 pi r over t equation here. So 2 pi times 1.5 meters over 1.2 seconds. And when you do this, you get a speed of 7.85 meters per second. And please use the pi button on your calculator so that it's not rounded. It's part A. Part B says, what is the centripetal acceleration? So now that you have the speed, it's just going to be v squared over r. So that's 7.85 plus all the other digits in your calculator squared, and the r was 1.5 meters. Do the math, and you should get 41.12 meters per second squared for part B. And the last one, number 6, says, at a carnival, one competition is to swing a bucket in a vertical circle without spilling any. If the distance from the person's shoulder to the bucket is 0.95 meters, so they're giving us the radius. So the radius is 0.95 meters from your shoulder where you're attached, your arm's attached to the bucket. What is the minimum speed required to keep the water from coming out of the bucket at the top of the swing? So we're up here at the top, and at the top there are 2 forces acting on the bucket. There's Fg acting down and Ft that you're supplying acting down. And so we know that the sum of the forces, or Fc, has to be equal to mv squared over r. They are both acting towards the center, so they're both going to be positive. Fg plus Ft equals mv squared over r. So for the water to stay in the bucket, these two sides have to be equal. So it asks for minimum speed. So minimum speed, you're going to slow it down, slow it down, slow it down. On this side is getting smaller, so this side has to. Fg can't get smaller, so it has to be the Ft that gets smaller and smaller and smaller as you slow it down, slow it down, slow it down. You will eventually hit the point where Ft is 0. That is the minimum speed. And so it becomes mv squared over r equal to g, and you're looking for v squared g times r. So 9.81 meters per second squared times the 0.95. Remember, that's v squared. So you're going to have to take the square root. So it's 3.053